Hi, good morning. My name is Mudawat Lakshman and I'm from CSC F section. So today I'm going to discuss about developing a linked list based task manager application in Java. So shall we go for introduction part? So introduction to task manager application. This presentation covers the development of task manager application using Java. The application utilizes a linked list data structure for managing tasks efficiently. Understanding linked list is essential for improving dynamic and flexible task management. So here, this project focuses on developing a task manager using Java, where all tasks data is stored and managed using a linked list data structure. The main goal is to efficiently add, delete, and view tasks dynamically. Unlike arrays, linked lists provide the flexibility to grow and shrink during program execution, making them ideal for a real-time task manager. Understanding how linked list function helps us implementing a robust and efficient program management system. So this is a introduction to the task management application, and we'll move for the why we have to use a linked list. So linked lists allow for dynamic memory allocation and easy insertion and deletion of task. So linked lists are used because the support of dynamic memory allocation, right? They provide better performance for frequent insertions and deletions compared to arrays. The structure offers a straightforward way to manage a list of tasks in flexible manner. So here linked lists are used for because support of dynamic memory allocation, meaning the memory grows as task increases. Unlike arrays that have a fixed size, linked lists can be expand and contract easily. They allow faster insertion and deletion operations without shifting elements. This makes them suitable for task management applications where the number of tasks often changes frequently. Okay, next we'll go for the basic concepts of linked list. A linked list consists of nodes where each node contains data and a reference to the next node. The first node in the list is called the head and the last node points to null. Operations like insertion, deletion, and traversal are fundamental to linked list management. So here a linked list consists of nodes where each node has two parts. One stores data and other stores a reference, or we can say it link to the next node yeah. The first node is called the head and the last node points to the null, marking the end of the list. Through these connections, data can be traversed easily. Operations such as insertion, deletion, and traversal are fundamental functionalities that make the linked list dynamic and powerful. And designing the task class. Designing the task class. The task class encapsulates task details such as description, priority, and due date. It provides constructors, getters, and setters for managing task attributes. This class serves as a data payload for each node in the linked list. So the task class is a foundation of the application. It stores important details like task name, description, due date, and priority. This class provides constructors to initialize these details and getter or setter methods for easy access. Each object of the task class becomes the content part of the node in the linked list, making it main element of the application's data model. So this is the designing of the task class. So we have to create the task class for the application. The task manager application, we have to create the task class. After that, creating the node class. So the node class contains a task object and reference to the next node. It provides constructors to initialize nodes with the task data. The node structure is fundamental for linking tasks in the linked list. So the node class defines the structure of each element in the linked list. Every node now creating the node class. The node class contains a task object and reference to the next node. It provides constructors to initialize nodes with the task data. The node structure is fundamental for the linking tasks in the list. So the node class defines the structure of each element in the linked list. Every node contains a task object and a reference to the next node. This class connects tasks in a chain-like structure, allowing the linked list to function properly. It also helps manage the dynamic linking and unlinking of tasks when user add or delete them. So this is a importance of the node class that we have to create in every linked list, so that it contains a data and a reference to the next node which is attached to it. So this is creating the node class. Yeah, building the linked list class. The linked list class manages nodes and provides methods for insertion, deletion, and traversal. It maintains a reference to the head node and tracks the size of the list. Encapsulating linked list operations promotes code reusability and clarity. So now the linked list class acts as a manager of all nodes. It keeps track of head node and provides methods to perform all major operations such as adding, deleting, and displaying tasks. It also maintains the size of the list. The class is crucial for ensuring modularity, meaning that all task operations are handled internally while the main program interacts through the defined method only. So this is the linked list class that acts manager of all nodes, and we can do such operations like adding, like inserting, deleting, displaying tasks, and all those things, and we can also maintain the size of the list. And implementing the insertion and deletion operation. So insertion and deletion are the most important operations in linked list. Insertion allows tasks to be added at the beginning and at the specific position, while deletion allows removing tasks as per usage size. Proper handling of special cases such as deleting of the first or last node, ensuring the program runs smoothly without errors. So methods for adding the tasks at the beginning, end, or specific positions are essential, right? Deleting methods handle removing tasks from various positions within the list. Proper handling of edge cases ensures robustness of list operations. So that like after, while deletion allows removing tasks as per user choice, proper handling of special cases such as deleting the first or last node ensures the program runs smoothly without errors. These operations reflects the flexibility and dynamic behavior of the linked list. Now we have to, like, the major role is to creating or developing a task manager application, so that we have to write the logic for the task manager application. So task manager application logic. The main application provides a menu driven interface for user interactions. Users can add, remove, view, or search tasks through command line operations. The application uses the linked list methods to perform these operations dynamically. The main application is menu driven. In the task manager application, the main application is menu driven, so that we can add any allowing users to choose from the options such as adding, deleting, searching, or displaying tasks. Every user action calls a corresponding linked list function internally. The system uses loops for continuing interaction and lets the user manages tasks dynamically through console inputs, simulating a real task management environment. Right. So this is a task manager application logic, so that the main thing in this task manager application is menu driven, so that allows the users to choose any adding of tasks or deleting of tasks or viewing of tasks or sorting of the tasks or anything, and handling user and user input and output. Scanner class is used for reading user input in the console. It clears prompts guide using users through the task management operations. Proper input validation prevents runtime errors and improves user experience. The Java scanner class is used to handle all user input from the console. Clear prompts guide users to enter task details or choose actions. Input validation is added to ensure users don't enter invalid data types or null values. The output is printed neatly, showing task list or confirmation messages, creating interactive and user-friendly experience. So now we are diving into the advantages of this linked list. Dynamic memory usage, no predefined size needed, easy insertion and deletion operations, efficient traversal for management multiple tasks, simplifies real-time data handling in applications, practical use of core Java and data structures principles. So these are the advantages. So the project demonstrates several advantages. It uses dynamic memory, so no fixed size is required. It allows fast insertion and deletion. It provides efficient traversal for checking and listing tasks. And it applies core Java and data structure principle to real-world scenario. The flexibility of linked list makes them ideal for building scalable applications like this one. What are the future scopes of the linked list and these task manager applications are: add a GUI interface for user-friendly interaction, integrate file storage to save tasks permanently, implement priority-based task sorting, extend project to mobile or web-based platforms, apply multi-threading for real-time updates. Like in the future, this application can be expanded by integrating a graphical user interface GUI for more user friendly experience. It can also include file handling to save tasks permanently, priority based sorting to manage important tasks first, and multi-threading for handling simultaneous operations. The system could even be upgraded into a mobile or web-based task manager for greater accessibility for the users that who are uses the platforms in the mobile and the web-based applications. Sample input and output. So like here we given our task finish DS assignment, and another task is prepare for exam. So now we are going to delete a task finish DS assignment and displaying the task. So the slide demonstrate a working example when a user adds tasks like finish DS assignment and prepare for exam, delete one and then display the list. The remaining tasks appear dynamically. This confirms the insertion and deletion are working correctly, and the linked list updates automatically without manual adjustments of indexes. What are the summary concepts of this project or this topic or this particular linked list and the task management application? The linked list provides a flexible structure for managing tasks dynamically. Proper implementation of node operations is crucial for application stability. Combining data structures with user input handling creates a functional task manager. So the project highlights how linked list provides flexibility for managing dynamic data efficiently. It emphasizes the importance of understanding node creation, traversal and data linking. This project shows how combining data structure with user input logic can lead to functional efficient applications, bridging the gap between the theory and the practice. And now we are going to conclusion. Developing a linked list based task manager demonstrates core Java programming skills. The application design emphasizes modularity, maintainability, and scalability. This project offers a foundational for more complex task management and data structure applications. So developing a linked list based task manager is a great way to understand how data structure works in a real application. This strengthens the concepts of Java OOP, improves problem solving ability, and demonstrate how modular design can make code scalable. The project lays a strong foundation for implementing advanced features and more complex systems in the future. So the references I used data structure and algorithm in Java by Rob, and the Java documentation tutorial from Oracle, online resources and tutorial on linked lists. So thank you so much.